Well, I might have to ask Emily to admit folks if she has the ability to while I'm talking. All right, welcome everyone. As I said, my name is Robert Villa. This is the first time that we've tried to use the U of A meeting spot, and unfortunately, there were some technical issues with the audio, so gonna have to iron those out before the next meeting. So I come to you from a beautiful lecture hall that hopefully in the future we'll all be able to, or some of us will be able to meet in as well as through Zoom. So we come to you from the University of Arizona, which is in the Sonoran Desert, traditional homeland of the A'atam people and many other indigenous groups. The Santa Catalinas to the north are named after a toad, which the Push Peak makes the snout of a toad if you're looking at the Santa Catalinas from the west. Before we continue, I'd like to remember Don Mall, who was a fellow THS member, sat on our board, and along with his brother Ed, was a world-renowned expert on the ecology and conservation of river turtles. We send our sympathies to Ed and Don's family. And yes, as well, I should say that David E. Brown passed away as well, another great naturalist of our region who furthered our understanding of the Southwest and its biomes significantly. As you know, we had a vote or an election for officers, and we are continuing to move forward. Once again, we have also granted 3 young researchers money to study desert tortoises, side-blotched lizards, and Gila monsters.
Oh,
We also recently helped with a very cool study on Dittmar's horned lizard, which is one of the most, well, one of the rarest lizards in North America. This is what
oh,
it's like. Here's some exciting exclamations. It is probably the shortest horned lizard, got the longest legs and shortest tail for living in rocky areas. This is,
sure.
here's some processing photos of some of the first moments in the field. And
Oh,
yeah.
Is he cute?
Very cute. We found on one hillside about 27 individuals. This is an amazing number. We also have the Sonoran Desert Toad Fund, which if you buy these cool items at this website, you can support efforts to understand populations of this toad and how they might be affected by a growing demand from the psychedelic market. We also have THS shirts and merchandise through our website at our storefront, Spreadshirt storefront. The shirts have a Gila monster, and the pattern of the Gila monster has a cryptic letters T, H, and S, the acronym for the Tucson Herp Society. And I'm very happy to announce that Christina Jones has been awarded the Jarko Conservation Award for her superlative contributions to the conservation of the amphibians and reptiles of the Sonoran Desert region. We are very happy again to have awarded her, and look out for details for a small reception and celebration in March. The numbers will probably have to be a little limited due to COVID protocols, and the venue will be holding that, but we can also broadcast that live on Zoom. All right, so I'm going to now introduce our speaker. Stop screen share. So perhaps there's never been a synergy more powerful than community science, where members of the public assist scientists with data collection and analysis, often remotely from great distances, to the great benefit of both parties. In 2020, Emily and colleagues initiated a major community science initiative, Project RattleCam, to give thousands of people the chance to collect data on rattlesnakes, while helping them accelerate data collection dramatically. Emily is a professor of biosciences at California Poly State University, San Luis Obispo, California, where she has been teaching and mentoring students in field-based environmental physiology research for 17 years. She fell in love with snakes as an undergraduate at UC Berkeley, where she conducted research on the Baja California rattlesnake, super cool, and wrote the senior thesis for her English major on the representation of the serpent in the Bible, which I would be very curious to read. She got her PhD in biosciences at ASU, Arizona State University, studying proximate mechanisms responsible for sexual size dimorphism in rattlesnakes. Emily is the 2022 president of the American Society of Ichthyologists and Herpetologists, and is on the board of Advocates for Snake Preservation, the last JARCO Conservation awardees. She keeps busy teaching classes ranging from herpetology to medical endocrinology, conducting research on lizards and snakes with her students, co-authoring an introductory biology textbook, and most recently starting a business, Central Coast Snake Services, that helps people in her local area coexist with snakes. Bravo, Emily. So with that, I will admit the 79th person into the waiting room and hand it over to Emily.
Hello, everybody. Let me get my screen shared here. All right. I'm super excited to be here, everyone. I hope that you can all hear me fine. I'm going to be talking to you today, like you heard from Robert, about this really exciting new project that we have, Project RattleCam. And I'm going to be showing you a lot of photos, a lot of videos, talking about a lot of ideas. There's not going to be very much data yet. And so I'm going to be talking a lot about the sort of data that I think that we're going to be collecting and asking for your opinions on what some of the things that we've been seeing mean. So I'm going to allow time for questions at the end, and I really would love to have a conversation with some of you. I was looking at the names of some of the people as we came in, and it's really exciting. So many people that I know, so many people whose opinions I really respect. And so thank you all for coming to listen to this. Really something that makes me really love what I do, you know? So I do a lot of research from rattlesnakes to local endangered lizards, ranging from endocrine work to thermal physiology and water balance work. But Project RattleCam is the thing that really, gives me dreams at night, makes me think about things when I'm walking my dog. I'm constantly worrying about this project now. So I'm really excited to share it all with you. It's very new, and it's, most of the things that we're seeing from this project that are popping up we're just seeing for the very first time right now. So thank you again for coming, and let's go ahead and get started. So I wanted to start by thanking the THS for inviting me. I gave a talk to THS as a graduate student sometime 20 years ago, and I thought I would do a quick nod to Tucson, which is one of my favorite places in the world. And I was actually just there. And so this is pretty funny. This, shows you all about, I guess, 21 years ago exactly now. There I was in a rattlesnake den outside of Tucson with, that was my PhD advisor, Dale DiNardo, looking on. And I think that he's in the audience right now. So hi, Dale. And then things don't really seem to change very much, except for on the right here, which was this month, earlier participating in some more Atrox research, Western Diamondback research, except that now I'm a little bit more conscious of the sun. And of course, I'm wearing my mask. And in this case, it's my husband, Steve, looking on. So most of my research lately has not been on Western Diamondbacks anymore, although they'll always hold a special place in my heart. Today, you're going to be hearing about work that I've been doing on prairie rattlesnakes in Colorado, and then also some more recent work that I've been doing on, well, whatever the rattlesnakes we have out here are, Southern or Northern Pacific rattlesnakes. We're right at what was been considered that traditional dividing line. So let's go ahead. All right. So I want you to look at this peak. We're at a high elevation in Colorado. It's about 7,500 feet at the base of this peak, about 8,000 feet at the top. Most of you who know rattlesnakes would walk by that, all surrounded by miles and miles of prairie, and you would go, oh boy, I bet I know what lives up there. And that's exactly what my friend and colleague, Dr. Scott Boback of Dickinson College, did years ago when he was visiting this private ranch on a hunting trip. This ranch is owned by his friends from high school. And so he asked permission, he went up there, and what he found was really astounding and really exciting. And he took me aside at the biology of the pit vipers meeting a couple of years ago and said, Emily, we need to get you up there. And so we did. And I'm going to tell you what we found up there. First, I'm going to show you what this place looks like from farther away. It's one of the most stunning places I've ever worked. Here are two colleagues standing on a hillside a little bit further away. So that is the peak that I was just showing you. It's called Rattlesnake Butte, and we're outside of Steamboat Springs. This is Dr. Bob Reed, who works for USGS. And then this is Jack Buck, who's a student who works with Scott Boback. And so what we're basically looking at is this just incredible vista, but nothing is more incredible than what you see when you actually get to the top of that mountain. This is what you see. So let me set the stage for you here. This last fall. I went up there, and there's a massive, massive den and rookery, or communal nursing area, of communal birthing and basically babysitting area of rattlesnakes. Go up there, all the snakes dive down the holes, and then I sat down right among them, perfectly still, and they start to come back out. And they kind of give me a little bit of a side eye, but then they realize I'm not moving. So I was able to sit and just watch them all. And so what you're seeing are dozens in this case, but on this little hillside, hundreds, even thousands, in about the area about half the size of a tennis court, perhaps, of prairie rattlesnakes coming out to bask. And the main theme of this talk is going to be something that many of you already know, but of course, which many people in the rest of the world and the rest of our country don't know, which is that rattlesnakes don't do what we see them do on Animal Planet, rattling and biting and hissing all the time, right? This is what they actually do. They actually, calmly crawl around amongst each other, mind their own business, look for a good spot to bask. And, again, to many people, it doesn't seem like they're doing very much, but if you look carefully, you can see a lot of different things. First of all, these rattlesnakes are incredibly fat, right? So some of these are still pregnant. This is a Labor Day weekend, and about half of the females hadn't given birth yet. And we can also see them hanging out with some babies from last year. If you look at the tail of this rattlesnake in the very middle, curving around, that reveals a yearling rattlesnake that probably never even left the hill. And they're really fat because they are eating a huge amount of food. These rattlesnakes, as is typical of many prairie rattlesnakes, are going to just leave the hill and go for kilometers around and eat a ton of rodents and come back up there and bring that rattlesnake biomass up to the hill. So of course, this is an opportunity that we cannot bypass. We've been doing a lot of things up there that I'm not really going to talk about today. We've been doing telemetry. So here is a scene from our mobile field lab where I'm putting radio transmitters, surgically implanting them into a bunch of snakes. We've studied some male snakes, but mostly we did a study on female snakes. When you have numbers like this, hundreds and hundreds of rattlesnakes, you can put radio transmitters in pregnant females and non-pregnant females and compare them. And that's how we've really learned a lot. But we also have been experimenting, because this is the kind of place where you can experiment. These are big snakes and there's lots of them. So we've been experimenting with external radio transmitters, like these transmitters that we actually tie and then epoxy to rattlesnake rattles. I'm not going to talk much about this today, but if you're curious, I'd be glad to answer questions. Limited success with these, as you might imagine. The surgically implanted ones are a little bit better. But again, these are all things that we're doing to study these snakes. And one of the main methods that we use, besides this radio telemetry, going around and looking at these animals, seeing what they do, what they're eating, was this photography. So this is something that Scott Boback, my colleague, had started doing the year before I joined. And we put these cameras on rookeries in the year I joined. So all around the hillside near the den where these snakes den up for the winter, the females, when they're pregnant, are going to move just right down the hill a little ways. They're still close to the top. And they get together in these communal birthing areas. They give birth to their babies and then they go back into the den. So they never leave the hill at all. They have a really short active season because we're up at 8,000 feet elevation. So they're basically coming up in April and May. The males and the non-pregnant females leave and move kilometers away in the beginning of June and come back in late or beginning of September. And then everybody gets back together at the dens in September and October. And then they're completely underground right now. They've been underground under the deep snow from November until about March or so. So what we did is we put cameras, and these are time-lapse cameras that take photos every 5 minutes on multiple rookeries throughout the area. So I think we had them on 3 or 4 this year, depending on some of them actually were contributing to the project I'm going to talk about, and some weren't. A few other things that you can see here are out in the front. We've got this thing that looks kind of like a pipe with rattlesnake print on it. That's an operative temperature model that we used for a thermal biology study that I'm going to mention today briefly, but not talk about too much. But just to let you know that there's a bunch of more traditional science going on, but one of the most exciting parts was this spying, rattlesnake voyeurism that we're doing with these cameras. So these are really high-end cameras. They do an incredible job, night, day. We can take incredible images of the animals. And with every 5 minutes, you get a good time lapse of what's going on. And so this is a typical picture that you might get after the snakes come out. And when I'm talking about these rookeries being really full of snakes, we're talking like 20, 30 pregnant females per rookery. We're learning a lot right now. I'm going to tell you how in just a minute, but the females seem like they might move around among rookeries. We're doing some research on why, how, etc. But we started to get these pictures back and we said, wow, look at all the cool things that's happening. And then we started to get stressed out because we had like over 60,000 photos to analyze. And it was just me and Scott and our students. And again, this is a side project for our normal research programs. So we thought, well, shoot, what the heck do we do? And this was all going on during COVID. We would all isolate for a month before we went out and shared time together in the field. And during COVID, I got into the habit of taking my dog Pax on really long walks. And whenever I go on walks, I get ideas. And so one of the main ideas that I got as walking was actually stimulated primarily by something that Harry Green told me. So Harry Green was my undergraduate mentor at UC Berkeley before I got my PhD with Dale DiNardo at Arizona State University. And I had written to him and told him about these snakes and about how we had all these photos that were coming out, showing them do really cool things, which I'm going to show you pretty soon. And he basically wrote back to me and said, Emily, God, we need to get people up there. And of course I said to him, we can't get people up there. First of all, it's incredibly remote, very hard to get to. Maybe about 5% of the people on the planet could actually walk up this hill. That's how difficult it is to climb up there. It's so steep. And also there's no oxygen up there. It's really hard to get up. And plus, a lot of us who know rattlesnakes worry that if people were able to have access to this area, that they would do something bad, like, kill the snakes or poison the snakes and that kind of thing. But this thing that he wrote to me in an email stuck with me as I was walking with my dog Pax. He basically said, my own experience says over and over and over, if you get people out there and show them the wild rattlesnakes doing their thing, it blows their minds. And so I couldn't let it be. I felt like I really needed to do what Harry said, which was to get people out there. But how to get people out there without putting the snakes at risk? How to get people out there when it's a private ranch and even I'm not there most of the year, we're just relying on cameras. How to get people out there when a lot of people couldn't physically make it up the hill, or maybe they live across the world. How can we share what we're learning about rattlesnakes with everyone else? And that's when it really hit me. Project RattleCam was born from this. So Project RattleCam is something that Scott and I and our students put our heads together and came up with. And it is a pretty major now, I hope to convince you about that, community science initiative where We have several main goals, which I'm going to describe in just a minute. But we are enlisting the help of the public in helping us analyze all those photos and having a lot of fun while we're doing it. Okay, so the main goals of Project RattleCam. The first one was what I've already told you, which is to use remote photography and videography. So that's going to be the second half of the talk, to learn about the behavior of undisturbed rattlesnakes. And this is really important to us too. A lot of you in the audience know this, that if you go up to a rattlesnake den or a rookery, the snakes don't behave like they normally do. They get scared of you. In Colorado, all those snakes, those prairie rattlesnakes, they dive down the hole, and only when I sit there still as a statue are they going to come out and actually behave. So we can learn more about what they do using this remote photography. Secondly, was to actually provide this opportunity for the public to participate in data collection and scientific research. So for those of you who've never heard of this, this is called community science, sometimes citizen science. And it's kind of in vogue right now because it's a really major goal of us to be able to bring our research kind of out of the ivory tower, out of the hands of a few scientists, and to engage the public with it. This is really important nowadays for scientific literacy, for understanding of what scientists do and why they do it. Probably every day more than it was before, as we see increasing amounts of everything from climate change denial to people not wanting to get vaccinated because they're not believing scientists. So all of these things are really important for us to do as scientists nowadays. And then, of course, the third thing that was really one of the major things that was up my sleeve this whole time was what Harry Green had initially said, which is if we can show people rattlesnakes doing natural and even exciting behaviors, and instead of those unnatural behaviors where a provoked rattlesnake is defending itself, that most people think is what rattlesnakes do, then I think we could actually improve their public image, which is something that over recent years has become very important to me. As an earlier scientist in my career, I was very interested in only the science. And now I'm just as interested in the science, and I'm also interested in the rattlesnake public image conundrum. So to move on from that, this is how we did it. So we put our project on Zooniverse. By the way, there's a typo there. I apologize for that. It's zooniverse.org, not zooniverse.com. And this is a community science hosting website. So it has dozens of community science projects that scientists have put up there. And it's pretty advanced. It's not like you just post your stuff and go. It took us about 6 months of very, very intense work to get our project ready. At one point, Scott and I were like, could we have finished analyzing our data ourselves by now? No, we wouldn't have. We have way too many photos. And now you can go on there and you can help scientists understand rattlesnake behavior. This is ours. And you can see these photos that have never been seen before by anyone, including us. So a random photo will pop up and you as a community scientist will help to analyze those photos. Before I go on and show you what it's like, the end goal is that after this is all done, we basically get a database that's been analyzed by multiple community scientists. In fact, each photo has 10 people looking at it. And we can do that then to be able to have an annotated list of like what snakes are doing in which photos, so that we can actually narrow down our research focus to, oh, we want to study social behavior. Here's the photos we can look at. Oh, we want to study their drinking behaviors. Here's the photos we can look at. So more on that coming up soon. Okay, so I'm going to take a minute to show you guys a 2-minute long video that you would see if you were to join Project RattleCam. The audio is a little loud, so you might want to be prepared to turn down your computers if it comes blaring out, because there's some cute music associated with it. So you can watch this as a greeting to Project RattleCam. All right, so I hope you like that and think that that would be something that would be exciting, even for maybe a non-rattlesnake lover. Like I say, maybe a rattlesnake curious person to see and to get involved in. And so I've already actually, by showing you that video, given away the punchlines, some of the things that we're studying, but I'm going to go through those with you now one by one. Okay, so the first thing is that this is what the photos look like. So each photo comes up randomly and it has the time and date stamp on the top left, as well as the temperature. And you can see snakes in the image. Sometimes the snakes have color-coded rattles. That means that we actually had caught them as part of our mark recapture study, and it helps us to be able to identify individuals from videography. Incidentally, in case you're still wondering, like, how many snakes there really are up here, in our first season, we were there for about 3 weeks, and we marked 375 prairie rattlesnakes from this area that, like I said before, is about half the size of a tennis court. So it's incredibly dense with snakes. Photos look like this. We also get some weird things happening, like this one just randomly caught a snake in mid-yawn. So these are, of course, since they're rookeries, they're probably also Ichthyologists or shedding areas. So this snake might be yawning to kind of loosen the skin around her mouth before she sheds, possibly. This shows you how good the photos can be at night. So sometimes it can be really hard to tell how many snakes there are in the photos, but it makes it really fun for participants to look around and try to see. And sometimes you can actually get the eye shine. You can count all those different faces with rattlesnakes all up in the background. So many snakes here, just all over the place. And then occasionally weird things happen, as they are wont to do in high elevation Colorado. So this was in September 8th of 2020. And we had this massive just snowstorm come through, and the snakes were all out, and it caught them off guard because it went from being, in the 40s Fahrenheit to below zero. In fact, look at this, -1 degree Celsius. And you think that might be very weird. Yeah, there's snow on the ground where there's rattlesnakes, but have you ever seen that with a rattlesnake out? No, there's a baby rattlesnake. It was born about a week and a half before this. We know when it was born because we can see when they first pop up, and it's out during the snow. No big deal, right? I mean, that's the first thing we've learned. A lot of natural history coming out of this project. We, of course, don't have the fully annotated database yet to do a lot of our actual science on it, but we are getting really cool natural history observations that lead to future research. How are these animals able to withstand these really cold temperatures? I'm not sure. There's the baby up close. Curled up, no big deal, it's just sub-freezing temperatures. So here's the research team before I go into some of the questions to tell you about. So that's me on the right in the pink pants. And then the two people I'm with are on the left, Maddie McIntyre, and in the center, Zoe Muller. Those are two undergraduates at Dickinson College, where they work with Scott Boback. In the middle there is Haley Crowell. She was my master's student at Cal Poly, and she's now a PhD student at University of Michigan. That is an anesthetized female, by the way, snake. It's a big female, showing you how big they get there. Down at the bottom there, we've got Dr. Rocky Parker from James Madison University on the bottom left, and he's holding a snake for Brandon Kong on the right, who is a student at UC Santa Cruz. And then on the far right here, we've got in the blue shirt, Dr. Matt Holding, who also was previously a master's student of mine, is now a postdoc at University of Michigan. And then the head honcho of it all, Scott Boback, in the red shirt. So this research team from 2020 and 2021 has people from 7 universities. And again, many different projects ranging from microbiome research to snake coloration to venom proteomics and so much more. And I'm only today telling you about the Project RattleCam component, where we bring parts of this to the public. So here's some research questions just to go through some vignettes with you, because again, this is all in the process. We don't have a bunch of data to show you yet. The first is, you're probably wondering how many snakes are actually at the den. So given the mark recapture that we did in earnest for the first year and a half, we are pretty sure, using these methods where we would paint the rattles, we put pit tags in all the snakes, radio transmitters in some of them, pretty sure that the area, the den itself, which again is a very small hilltop, has at least 1,500 prairie rattlesnakes. So it is a big den by any account. There are bigger ones out there, but maybe not in such a small area. So pretty impressive, the size of this den and the things that we're able to then do because of the opportunity. You can see here that we oftentimes will get these snakes with color rattles on the screen, and the questions that they ask on Zooniverse are, it's a path, right? It says, is there a snake or is there not a snake? Sometimes there's no snakes. If there's a yes, then it takes them to the next question, which is how many adults, how many babies? Do any of them have these colored rattles? And so we have these community scientists basically telling us the color codes of the rattles so that we can then go back and analyze what the different females are doing. Are they moving from rookery to rookery? Yes, they are. Spoiler. Why? That we don't know yet. One of the major research questions that we're really interested in is how do mothers and newborn babies interact? And this, there's a lot of different layers to this. So Zoe Mueller, one of the students who I showed you earlier, is doing an analysis. We've caught a lot of babies and a lot of mothers and males as well. And she's doing, she's studying them to look and see, okay, so are these is that actually the mother and those her babies, or is this a pregnant female who is, babysitting is a word oftentimes used, someone else's babies. Are the females that hang out at the rookeries together, are they related? These are all questions that we don't have the answers to yet, but we hope to have them at some point soon. But you can take a look at the kind of thing that we see. So here's a picture from June, which is just, right around now is when the other, the non-pregnant females and the males would have all gone off the hill. And so just the big, fat, pregnant females stay behind. And you can see we still have some green grass. It's still early in the year. And they just bask out in front of these rock crevices all day long and go under. And then about 2 months later, we see something change. And what you now see is that we've got dark, dead grasses because it's now middle of August. And now all of a sudden we've got babies curled up with the mothers. And one more thing is the mothers are now very, very, very thin because they've lost all of this weight. And many of us know how rattlesnake reproduction works, right? They have live birth. They put a whole bunch of their body weight into reproduction. The fascinating thing about these prairie rattlesnakes is because they have such a short active season, and they do not leave the hillside. These prairie rattlesnakes, with very few exceptions, do not eat at all the entire time during pregnancy, and not afterwards in that fall either. So sometimes we see a situation where a pregnant female won't eat for many months, but then as soon as she gives birth, that's how the story goes, right? She gives birth, the baby sheds, she goes away and she hunts. Well, that's not what happens here. These will just go back down into hibernation. So by the time a female is able to actually eat, it's the next summer. And it's probably been over 18 months since she's had a meal. So this is one of the more extreme lengths of time that we think in between feeding. And we think that one of the reasons that they can do this is because they have such a short active season. There's, all when they're hibernating, they're down just barely under the snow line, and their body temperatures are about 4 degrees Celsius because we've had data loggers in them. And so they're just not spending much energy, and they're kind of in this stasis. So they seem to be really well adapted to be able to do this. This, by the way, was this photo was the stimulus for us to make our Project RattleCam logo, showing the mother rattlesnake, of course, very bambified in this case, snuggling these rattlesnake pups. Why they do it is anyone's question. I think that it probably is really complex. There's no reason why it should be one thing. We've watched them enough now to know that the baby rattlesnakes and the mothers do like to be in contact. But is it because of thermoregulation? Is it because it helps them to reduce their evaporative water loss across their skin? Maybe it's one or both of those. Maybe it's other things as well, safety in numbers and so on, but maybe it's also for social reasons. These are all the things that we'll be able to get a little bit more handle on by studying this system. Okay, so I want to show you a series of movies now that I took this past Labor Day weekend, showing a brand new litter. Well, not brand new. They were probably born maybe 4 or 5 days before because they've got blue eyes. This is in the morning. The first thing you'll see when you go up to a crevice is just a bunch of baby rattlesnakes. And I want to tell you all that this hillside, no matter where you look, there's just piles of baby rattlesnakes. So many mothers, so many births happening. They're kind of cold right now. They're shuttling in and out, moving pretty slowly. A little bit later, they've warmed up a little more, so they're a little bit more wiggly. And I would have hiked up there. What are they all doing? Where's the mother, or whatever? And it turns out that if you just wait a little while longer and you come back to that same spot, you'll see this. Hang on, I got to move the zoom bar out of the way to click play here. There we go. Sometimes if you don't look carefully, you won't even see it, but does everyone see mothers or maybe aunties or just another female's watchful eye? Definitely seems like she's giving me stink eye. She's basically very, very quiet. Don't touch my babies. Okay, so one of the questions that we're really curious about is about the rattlesnake's water balance. This is an incredibly dry area, very little rainfall, and they have a very short active season. And a paper came out a couple of years ago by Dale DiNardo, my former PhD advisor, showing that rattlesnakes cannot get all the water that they need just from eating a meal. They actually do need to drink. And many of us have been lucky enough to see rattlesnakes drinking in the field. And this remote photography and remote videography is a great way to do it, especially to do it that's not just anecdotal, to actually get, collect data on it. So I had my artist friend do a comic about how they do it. We have evidence now that the second that it starts sprinkling at the site, even if the snakes are underground, out they come in mass, because if it's sprinkling in one picture, 5 minutes later, there's snakes everywhere, and they curl up and they turn themselves into little bowls, and they drink off of their own scales and they drink off of each other. They flatten themselves down. Recent research has shown that they actually have these microscopic little structures in their skin that help the water to bead up so that they can drink it off of their skin. And the number of photos that we have of these animals drinking the water is incredible. So here's one right after the babies were born, showing flattened down disc-like, bowl-like snakes drinking off of each other, the babies drinking off of the mothers. And this is the first time that to our knowledge, that we've ever been able to observe the fact that the babies are born thirsty. Babies will come out and it's instinctive for them to drink water and to flatten their bodies into little discs just a couple days after they emerge. So maybe just a few days after they were born, which is pretty awesome, I think. And people like this, people like to see this behavior. So I think this is another great form of outreach. Many people think it's really cute. Here's a video taken by Scott Boback of a neonate prairie rattlesnake. In this case, it's actually not natural rainwater. We're simulating rainwater as part of an experiment. And it's just drinking. It moves around. Sometimes they move clockwise, sometimes they move counterclockwise. Who knows? So much research to be done on these animals and how they get their water. We're curious about what preys on these rattlesnakes. So I told you that these rattlesnakes move for, miles away, even every summer, and they eat all those rodents, and then they bring that biomass back to the hillside. And so clearly these predators know for miles around that this is basically just a smorgasbord of snake sausages to come and eat every single active season, all from April through October. You can just come and snack on rattlesnakes if you're willing to take a risk. And so we built, and Zooniverse, we built that in to where we have all these photos. This is a photo that was taken with one of our cameras that shows a hawk over here that is preying on one of the rattlesnakes. And so we used all this to build a field guide so that if someone happens to come across a photo, and again, remember, these aren't photos that we just put up there being like, oh, here's one of them eating. These are all the photos. And we haven't even seen these photos. It's community scientists who are helping us to see these. Every day I'll get emails saying, someone found this, someone found a bobcat, someone found a mountain lion. Oh my God, So what we did was make this field guide so that if they did find something, they could identify it and they can tell us what it is that they're seeing. So in this case, this was a red-tailed hawk who is preying upon this rattlesnake. The birds are definitely the main predators. Here is a time lapse. So this was actually an infrared camera. So it was motion activated, which is why if you look at the time on the top, it's every second or so. And it's just grabbing and throwing around a baby rattlesnake. It's magpie. Magpies are major predators of rattlesnakes on this hillside. And maybe a lot of y'all know that, but I didn't know that. And I think it was really cool to be able to see that they just come up there and snack on the baby rattlesnakes like crazy. So definitely birds. We've seen a lot of other animals up there. We've seen things that probably aren't predators that are just getting in the snakes, getting in, around the snakes a lot, like a lot of elk coming up there. Marmots do this weird thing where they don't interact with the snakes, but if the snakes are underground, they get in there and they like to poop in the rookery for some reason. And it seems like they're also grabbing the shed skins. And we wonder if they're doing something with the shed skins, like cutting it up and rubbing it on themselves, much like the California ground squirrels do. We don't have any images of them doing that, but they seem to grab and chew up the rattlesnake skins. Don't know why. We've done so much now with this project. We're just in the first year of it being active. It's been active for about 9 months. Really excited about this. So we've made teacher materials. This has been a colleague of mine did this for her class, and then a student of mine for her senior project took those and changed those. So any of you who are teachers, high school or college teachers at all, who want to do a virtual lab experiment or something that we've done in person, we have set customizable materials. So it's a Word document, so you can take it and then you can just make it yours. and you can use it in your classroom. And this is really the major goal here, right? Is we're trying to get this studying these animals kind of out where everyone else can see them. So this is the end of the first part of the talk, and I'm going to go into the second one, but I wanted to kind of give a plug. If any of you are interested in helping with Project RattleCam, it's really fun, it's really addictive. So I'll usually spend about 20 minutes every morning when I'm drinking my coffee classifying photos myself so that I can always see what's going on. And look at the statistics, it's pretty mind-boggling. We've had over 5,500 people who have been classifying photos for Project RattleCam. I mean, never in anything I've ever done have I had remotely even close to that reach in terms of the number of people who are able to interact with rattlesnakes. There's been over 343,000 pictures classified. So remember, each one gets classified by, when I say classified, I mean like how many snakes are there, are there colored rattles, by 10 different people. So of the 60,000 photos, 42,000 of them are done. They've had at least 10 people look at them. So we're 70% of the way there. And once we are 100% of the way there, then we'll have all that data to get in there and really kind of answer these scientific questions. And maybe in a year or two, I can come back and give a talk about the actual findings. So if you're curious about joining, you can go to zooniverse.org. So that's correct, it's not .com. You can go there and you can search for Project RattleCam. It's a free account. If you know someone who might be interested, we generally recommend it for people who are high school and up. Maybe someone who's a very, a younger person who's really serious could actually do it as well too. And so I hope that you'll join us with that. And these are the kind of things we see on social media, because we're heavily involved in social media on this, is someone saying they took a quick break to count rattlesnakes and they spent non-zero minutes cooing over the babies gallery. So there's galleries where you can go in and see these piles of baby rattlesnakes. And I agree. And so this person, thought that the babies were cute. And this is actually an important thing. There's a lot of recent research coming out that suggests that people's opinion about the value of wildlife depends largely on how cute or beautiful they are. And contrary to what I used to think, not on whether they're harmful or not on whether we think that they are like intelligent. It's mainly how cute they are. And so if we can have people thinking that rattlesnakes are cute or are slightly less threatening looking in terms of their appearance, then that could be a helpful thing for rattlesnake conservation. Okay, so moving into the second half of the talk. Again, I was in another pandemic walk with my dog, brooding and thinking about life. And I thought to myself, oh my gosh, you know what? We need to step this up a notch. And this was all inspired by something that goes on at my alma mater, UC Berkeley, where I got my bachelor's degree. And they have a series of live streaming cameras on their peregrine falcons. And these live streaming cameras show from 3 different angles, these Annie and Grinnell, which are the male and female pair, and they're named after the founders of the Museum of Vertebrate Zoology there, which is really cool. It shows them raising their chicks each year. So has them bringing in birds to feed them, and it's totally addictive. And I will be sitting there doing my work and then have the Cal Falcon cam like live on another monitor as I'm doing my work, because it's just totally addictive. And so I thought, why don't we do that for rattlesnakes? I looked it up and I couldn't find anyone who had really had a serious live streaming camera, as in live streaming to YouTube, so that other people can just log in and watch rattlesnakes in real time. No one had done it. And so I looked into it and it was really difficult. This is not something that you just buy a camera and set it up. These are remote areas. You have connectivity issues. You have to have a fixed IP address. So it's not easy you can't just use your cell phone. It's really hard and it's really, really expensive. So I wrote a grant and I got it. And here's what happened. I have an area here locally that has a Southern Pacific rattlesnake rookery. And this is a photo from 2020 that we found this rookery. And actually the cool thing about this is that this rookery was found by a then 12-year-old student named Wyatt, who called me in excitement, told me about it, and then showed it to me and shared his rookery with me. And so it's an undisclosed area because we keep it secret. And this is a clearly still pregnant female hanging out with 2 babies from two of someone else's babies. And this site, unlike the one in Colorado, we don't touch any of the animals. This is completely hands off. We're just observing them from far away. And as much as I would like to be up there all day, I would just be able to sneak up, once a week or something, because, again, not easy to get to these places, and see what the snakes are doing. And I thought, a live streaming camera, it's close enough to where I could troubleshoot. It's our local snakes. We had a local grant. Let's do it. So we did it. And this makes it look easy, but it was not easy. So that whole device that you're seeing there, which is a security camera, and it's a special type of security camera that has software that live streams to YouTube. Is all housed in a special custom made housing with like, it's full of, it has a GPS device on the inside. So if someone stole it, I could track it. This is all mounted with, you know, custom made camouflage tape so that people can't see it. It's pretty impressive. I just want to put a plug in here for the engineers at my university who do this kind of stuff for me all the time. It's one of the benefits from working at a polytechnic university. And of course, you know, you can't have a power supply up there. So this was all solar powered system. And so there's the camera on the Rattlesnake Rookery over there. And then here's a pretty big solar power array, because you can see that where we are on the Central Coast, you have to have that. It gets foggy sometimes. And so we had to be able to have continuous power for 3 days, even without sunlight. So the results were pretty awesome. This is a much smaller rookery than the ones in Colorado. So there weren't as many snakes, but it was still pretty great. So it was all over the news. It was, you know, locally in California, but it was even on, I'm sorry, locally in San Luis Obispo, but some other places in California too, saying, you want to watch these snakes from home? Go ahead. And here's what it would typically look like. So we played around with these for a while. So here's when we had a lower quality setting, which basically allowed us to get kind of more, how do I put this? It was expensive. So we tried to do the lower quality. Now you should be watching what's happening as the snake's emerging on the left. Don't watch the right-hand side of your screen too, because there's a little surprise happening. Anyway, so it's a little bit jerky on the lower quality, but it's a little bit cheaper, which means that we had like $1,000 budget for streaming for 2 months. And so we could maybe get more, we thought. So hopefully everyone has seen that this rattlesnake is crawling around. This is a pregnant female that my students named Fusey Susie. And then, oh, there's a gopher snake over there. Look what happens when the gopher snake sees the rattlesnake. Goodbye. Bye, you didn't see me. Which is totally funny, right? So just so many little natural history vignettes there. Why was the gopher snake? Why did it do that? I don't know. But so this is kind of the, you know, lower quality setting, but look at how great it can be with a higher quality setting. I'm gonna show you next. It costs a little more. So first of all, I want you to know that this is a incredibly impressive camera, because I'm sitting at home on my laptop. I could have been in Fiji on my laptop doing this. And in fact, I was in Mexico remotely operating it at one point from the beach. And I can zoom in, I can toggle, I can pan and tilt, I can follow snakes around. So here's a zoomed video, and look at that quality. Isn't that incredible? Of another one of our snakes who is preparing to shed. And so that's just, by the way, that's just a one-time yawn. It's just on a loop. But you can see that if I had an unlimited budget, or if I could get Verizon to stop pillaging me with a crazy data plan, then we'd be able to get just the most epic footage of these snakes. Here is what you can get when you zoom way in. So you can get great still photography when it's on the highest settings. So this snake was completely invisible. You never would see her from the pathway if you walked by, and indeed there's a trail right next to it. But she's, you know, you can zoom in and we can see a few different things from this, you know, and this is what I loved so much. I'd be on YouTube and talking to people because people are watching it live with me. And there was a whole community of folks who are just watching this and asking me questions, and I'm answering them. The things we can see here is how much she blends in, but you can also see, if you look carefully over here, that you can see how her scales are stretched dramatically. And that means that the snake is still pregnant. She hasn't given birth yet. And we were able to watch each snake every day and see how they had habits and see how they like to hang out with specific other individuals. All the snakes got named by my students. After they gave birth, you could see a dramatic difference. So on the right-hand side here is one that's still pregnant. We can see how fat she still is. And then over here is the very thin tail now with these skin folds of a recently birthed female. Now, one of the most shocking things about this was, as this was all happening, I was expecting to see things like I had always heard, which is, oh, pregnant females, they give birth, they hang out with the babies, and the babies shed 10 days later and everybody leaves. In Colorado, that seems to be the case, except that everybody doesn't leave because the rookeries are the hibernaculus, so they just stay. But we never knew whose mothers were whose. And so with this case, by watching them all day, every day, we could actually see what everybody was doing. And we could see that, no, the mothers who just gave birth were not hanging out with their babies. The mothers who just gave birth never hung out with babies. They hung out like this for a little while and then they were gone. It was the babies that were still there were hanging out with the pregnant females that had not given birth yet. And I'm not the first person to say this. You know, there's people who, like Melissa Amarello and Jeff Smith, have been saying this for years, that these still pregnant female rattlesnakes will babysit, is what we call it, for these other snakes. but the mothers were not hanging out with their own babies, at least from what we could see at all. So we by popular demand, we made a guide to all the different snakes. We found some really cool things. We found that the males would come and visit the rookeries, including Drogon and Viserion, which were two of the males named after Game of Thrones dragons. One of them shown up there. And we made these guides so that community scientists could help us figure out who is who by looking at their rattles and their unique markings. And people were good at it. People would on Twitter be like, "Oh, Susie's out." It was really exciting. So here, finally, the babies were born. Finally, the babies came late this year. It was stressing me out. They came in October, beginning of October. And here we see on the right-hand side, everybody's favorite rattlesnake, Macaroni was her name, all named by my students at Cal Poly who were monitoring, hanging out here with someone else's baby. And so you can see here now, I'm operating the camera, so it's gonna be panning and tilting. So you can see how it works in real time. And I'll be zooming in just a minute. But watch Macaroni as this baby comes up to hang out with her. Huge area the baby could be, but it wants to be on this female here. So she kind of moves and just makes a little spot for that snake, and she doesn't care if it's sitting on her head. And there's my zoom. So again, we can see just how incredible it is. And you can really zoom. I could zoom in and get just epic high definition right on that baby's face if I wanted to. Some of you might be wondering how far away the camera is. The camera's about 10 feet away at this point. And so we can zoom in very, very, very well. Again, this has to do with the fact that this is there's a nice little yawn at the end. This is about $1,000 camera. The whole rig was about $10,000. So that just goes to show you, compared to just a regular remote camera, what it can do. And so, yeah, this was, my universe was excited. People got into it. It was all over social media. There's some babies. Here they were with Susie, some of the other snakes. We saw all kinds of things happening. We saw lots of babies curled up with soon-to-be mothers. We saw lots of male rattlesnakes courting pregnant females. And when I say courting, I don't mean just a little bit of a chin rub. I mean vigorously courting pregnant females. That's what they wanted to mate with them, which is not something that I was aware happened in all my years studying rattlesnakes. I've never seen that happen. And I asked a lot of other rattlesnake experts on social media, and most people say, yeah, you'll see a little bit of chin rubbing, but not the vigorous courtship that we saw constantly. So more things that we're learning from these sites. And then my favorite part was how schools started to use this. So even better than showing these to students on time lapse, is showing them in real time, saying live, right here, right next door on the Central Coast, this is what's happening, and having these kids be able to watch these snakes and learn about them when they're young, because nothing better than learning about these animals when you're young to make you a lifelong lover of snakes. I've always said that rattlesnakes are the gateway drug for naturalists, so that if students can love them when they're young, then hopefully not only will they maybe grow up to be naturalists, but maybe they'll convince their parents to think rattlesnakes are all right as well. So thank you to Mrs. Brooks's class at Solving Elementary School for letting her students study the snakes. So just one more thing before we leave was, a lot of this is, as you can see, is outreach, right? This is science, but we are doing science and outreach at the same time, which is something I'm really excited about. And, this is something that I've become much more involved with recently since joining the board of advocates for snake preservation, who frankly have been doing this for a long time. They're the ones who do all this outreach. They're the ones who are actually thinking about what they're saying, whereas I've been stumbling through it for a long time. And so I started to get really interested in, what difference is, like, what I'm saying to people and what we're showing them rattlesnakes doing, does it matter in terms of how much they're impacted, in terms of what they think about rattlesnakes? And so I mentioned that on a podcast recently. It's like, I wish some graduate student would study that. It was the So Much Pingle podcast. And I got a call or an email from a graduate student and her advisor in West Virginia, and they wanted to do it. And specifically, they wanted to study whether the message that we might give to people about ecosystem services, like, oh, rattlesnakes are an important mesopredator, right? They eat rodents, they get eaten by these beloved top predators. Is that effective, or is it more effective to actually show these, like, mothers and babies and these babysitting aunties and whatever, anthropomorphizing them, talking about their social lives? Which one's going to move people who don't like rattlesnakes more? And so this research is actually underway right now, and I have a preliminary slide to show you that was given to me by Erin Allison. Her name's at the bottom there, and her advisor Zach Loffman. So they're at West Liberty University, and this is their research. So I'm just helping with a little bit, but it's pretty awesome if you look at it. So what they did is they made a survey about rattlesnakes. People would take the survey about rattlesnakes. And then they would watch either one movie showing like rattlesnakes eating rodents, ecosystem services, or another one about rattlesnake mothers and babies and their social lives. And then they would take the survey again right afterwards. And so that's the pre versus post. And so this is all in the process of being analyzed right now. This is the closest thing to data that you're seeing tonight. So it's all very preliminary, but what you can see though is very noticeable, and this is quantifiable too. The increase in the favorability scores in terms of what people think about rattlesnakes, it was slightly apparent with ecosystem services, but more apparent with social lives. In other words, this instinct that I've had that talking about mother rattlesnakes and babies, it can move people is a good public relations campaign for rattlesnakes appears to actually be the case, which is pretty exciting. So stay tuned for more from Erin, Allison, and her advisor, Zach, on that as time goes on. And this is the kind of thing we see as, when we shut off the cameras in October because we ran out of our Verizon pillage fund, people would post on Twitter, goodbye, I felt privileged to be able to witness something so extraordinary. They said it's deeply moving to see the relationship of the babies to mom. And of course, we don't know what that relationship is, right? Clearly it is social, but we don't know why, but it's happening, it really is. And so it is moving people. So this is evidence enough right here. Someone recently wrote to me and said, as someone who had only the occasional interaction with snakes in the trail, I was surprised myself in becoming completely enamored with a snake den. This is the live stream. I surprised myself further by being slightly shattered when the camera came down. And I'm with this person. I went into like a depression when the camera came down because I was watching them all day, every day. Y'all, when I was teaching, I had my laptop up right here teaching, and then I had another laptop with the live stream going so I could watch it at the same time. It was all consuming. It became a lovely ritual learning the habits and personalities of our snake neighbors. So to me, to have the opportunity to be able to share what rattlesnakes do with the world like this has been incredibly rewarding. I really want to put a live streaming camera on the Colorado snakes next year. Because if I could put a live streaming camera on the Colorado snakes next year, can you imagine piles of hundreds or thousands of snakes and the cool things we would see, the predation, all the awesome things we could see? So we are working on it. I just submitted a big grant for that. I'm always doing fundraising. So if there's any donors who want to donate to the Verizon Pillage Fund, let me know. There's some additional, also just if any of you are really tech savvy, I'm experiencing some technological challenges, and I don't mean like little ones. I mean, I'm in an engineering university and none of my engineers can figure it out in terms of how to get these things streaming in remote areas. Please hit me up because I would love your help. And so with that, I am going to stop and ask for questions and thank everyone for coming and thank everyone for listening to me talking about rattlesnakes. I assured Robert that I wouldn't talk for too long. I probably did anyway. It's already 7. But if there's any questions and so on, I would love to answer them. And thank you so much for listening.
Thank you, Emily. That was superb and exciting, and just goes to show how rattlesnakes are the gateway drug for naturalists. And
I think so. Should I stop sharing or what do you think?
I think it'd be best to leave this wonderful photo up, and you and I can look at questions that people may have in the chat. Let's see.
Yeah, and why don't you just ask me the questions in the chat? I'll let you kind of go through those and I'll answer them.
Okay.
Because you can like pick which ones you think would be best.
So the first one is from Mike and Denise. And
Hi, Mike and Denise.
They ask, how long do reproductive females survive, and how many broods might they have in a lifetime?
Yeah, so this is coming from Mike, who studies Mojave rattlesnakes, accomplished field biologist. So I would say that our knowledge of that is with the prairie rattlesnakes is as limited as it is for most of the species we've studied, because we've only been studying them since 2020, marking them. I can tell you that the mortality is pretty high. A lot of the post-reproductive females go down in the den for the winter and don't come back up. So I think that they're so skinny, they go down there and they're dying. We know this from doing the telemetry and mark recapture studies. We can hear the radio ping down there, but I don't have a good answer for you. I can also tell you that there's just some of these females are big and old. And so it suggests that they've been around a while, and it looks like they're giving birth every 2 years, sometimes every 3 years at this site. So pretty fast. They're pretty similar to a Western Diamondback, I would say, just with a much shorter active season. Was that the full question? I'm not sure I got everything.
I think so.
Okay.
Taria Linala says we were surprised how big the babies were at Central Coast campsite.
Yes, yes. This year was weird. So the live stream, the babies were few and they were big. And sometimes in snakes, there's a trade-off between numbers of babies and the size of babies. This year was really weird. We were in a historic drought in California. And I think that a lot of females didn't have babies or may have resorbed some of their follicles early on. So they possibly had smaller number of bigger babies. This is all just conjecture. I don't know, except I can definitely tell you that it seems for sure that there was really, really big babies. At the Colorado site where there's lots of babies we can look at, they vary incredibly. They vary by a huge amount, by probably like 100%. Like some of the brand new babies are twice as heavy as some of the other ones. So it has to do probably with the mother's condition and a lot of other things too.
Jeff Lem says, thank you, Emily. Awesome work. And he asks, which cameras are you using with the Viridis?
Yeah, so I'll have to look up the actual model, Jeff, but Axis is the brand. And I did just an obscene amount of research to select the correct one, including interviewing a ton of companies. I should have mentioned this before, given how many rattlesnake biologists like Jeff are on the call right now, but my dream is to have a network of these cameras on rattlesnakes all over the country. So Jeff, if you know a ruber or Helleroy den that needs monitoring, let's talk, because I've talked to people like some herpers from Phoenix area who watch snakes like this, and they say things like, you go ahead and get all the kinks figured out and tell us how to do it so we can do it later on. But I just dream of having this page where all the YouTube live streams are on it and you can just click on different ones and watch the different snakes doing things. So contact me, Jeff, and I'll hook you up with anyone who wants to know how it's all done. Let me know. I would love to have more of these systems happening.
Cool. TBL3 asks, are there any plans to crowdsource the Colorado data analysis or at least make it publicly available?
Great question. Yeah, so the Colorado data analysis, we haven't gotten that far in terms of how we're going to crowdsource that, but that would be incredible. The idea is including community scientists in the data analysis as well. And so I'll thank TBL. I think that was the initials for that suggestion, because now that has reminded me I need to talk to Scott Boback about that. I do think that that is kind of the next level community science. It's really awesome. The data set is going to be public. It's just a matter of when, right? So a lot of times scientists like to take a first stab at looking at some of the data. But actually, now that you're mentioning it, it might be pretty cool to have some people help us with the data analysis, which would be really, really cool too. So right now we're just like, let's get the data collected and then we'll see about analyzing it. So stay tuned. Everyone should follow us at RattleCams to hear all about the different methods. A lot of people are coming in now. I wonder if people had a time zone hour off, do you think?
I wonder.
Yeah.
So Dawn Browning, D-A-W-N, Browning, PhD. Great job, Emily. I might be able to help with telecon issues.
Ooh, that would be great. So Dawn Browning, by the way, everyone's my best friend. We met when I was 20 years old doing herp surveys in South Dakota. So hi, Dawn. And yes, I will hit you up, girl.
Thomas, cool talk. Any idea what the demographic is for the people participating in the Zooniverse?
No, we don't have those data. We do not have those data at all. I really wish that we did. I don't know if I'm not sure if that kind of metadata is available. That's an interesting idea. I will say that we do have those data for the rattlesnake survey, Erin Allison's rattlesnake survey that I talked about at the end. So she's going to be looking at how things like age and whether you live in a rural area and whether you know someone who's been bitten by a rattlesnake, how all of those things interact to help to impact people's perception of rattlesnakes. But we don't have the data for the project, no.
Cassidy Lee asks, where are the surgical trackers placed on the rattlesnakes?
Yeah, great question. The surgical trackers are placed right, basically, if you have a big male, you're going to put it, so it's under the skin, under the muscle, so alongside the organs. And it's going to go right kind of between where the liver stops and the stomach starts. So it's like a place where you're not going to, when they eat a meal, it's not going to be distended. Sometimes in the pregnant snakes, we put it a little bit more anterior because they're stuffed a little bit more towards the head because they're stuffed so full of fetuses that we have to make sure that we leave room for fetuses. And these snakes are incredibly resilient. They do perfectly fine with these surgeries. So yeah, so the transmitters are about half the size of a lipstick container, about that big. And we put them only in big snakes, so it works pretty well.
Smetlogik asks, average time a volunteer would spend on viewing.
Yeah, those data are out there too, but you have to go person by person to see how much time the volunteers spend doing this. Some people come in, I don't have the data on average. Some people come in, they just do a few of them, they stop. There's a lot of people who come back and just do a few every week, but there are several volunteers who have classified thousands and thousands of photos. So I'm like, I need to find them so we can see if they want to be an author on some of our publications coming up because they've participated so much in the data collection.
Brian Sullivan says, great presentation. Curious, do you think protolids, quote unquote, need more water than other snakes? I have never seen any colubrids drinking.
Such a good question. Okay, so Brian Sullivan, hi Brian, by the way, says, do crotalids need more water? I've never seen non-crotalids drinking. So I have definitely seen non-crotalids drinking, but I know what he's saying. Like rattlesnakes, we see it a lot more often. A couple things. First of all, is what we see, it may be biased by where we live, first of all, being like the desert for you all, and also Colorado, which might as well be a desert. That's because the snakes that live there tend to drink more often. I'm not answering this correctly. The analysis that was done on the drinking behavior and on the architecture of the skin, where the water beads up so that the snakes can drink, they actually looked at that and they found that this architecture tends to be convergently evolved in snakes that live in dry areas. So indeed, the drinking behavior tends to be something that we see a lot more in like viperids, especially vipers that are like it's convergent evolution with vipers that live in like foggy areas, foggy desert areas, in the Namib Desert, for example, and also in Arizona. So I've seen like coach whips drinking in Anza Borrego. I've seen coach whips drinking in the Mojave National Preserve. And so I would say that it's more habitat than anything else. Whereas something like a garter snake, which is probably getting plenty of water by, swimming in it, living in it, eating lots more prey. And that's another thing too, is colubrids just usually eat more prey than rattlesnakes too. So maybe they're getting more water that way. It's a possibility. I know that there's been some recent studies that are not published yet looking at like kind of the other side of that, which is like evaporation across their skin and how that's impacted. And the animals that live in a desert area have less evaporation across their skin. So they're keeping more of their water, little water tanks. But I think that it's also the idea is that when they get water, they're going to drink more. When they have water available, they'll drink more of it too. Great question.
So there are a ton of questions and I'll try and get through as many as possible. And Emily, I would say if there's any of those that you prefer to answer or are attracted to, go ahead.
You pick them because I'm not looking at them. So
okay.
I'm just staring at this beautiful speckled rattlesnake in the eye right now.
Okay.
You're the host, so you can pick them.
Okay. I'm going to start just choosing at random. Let's see. Great presentation. This is from Bob Beasy. Great presentation. Have you encountered any problems such as vandalism or other negative activity from the community?
Yeah, that's a great question, Bob. One that we were very worried about, given that these cameras are so expensive. So the Colorado site is on a private ranch, so no one can get up there. It's perfectly safe, which is one of the other reasons why it's such a great place to work. The site in California is not. It's in a public area, and we were very worried about it. And we went to great lengths to camouflage it, to put GPS tracking devices in there. And as it turned out, nobody cared. I mean, we could have been lucky, but no, nobody messed with it. We did have a couple of times when we'd be on the live stream and we'd see people, like you'd see some shadows come up and then someone would stick their face down in front of it. So, but they usually seem to be like people who may have already known about it anyway through me would like wave at me or something. So I think it is a major concern if we're talking about putting these up in public areas. vandalism is a major concern. So I've gotten lucky so far, and then also putting them in really remote areas where people can't go, especially private areas, is ideal.
Cindy Rossler, did you say neonate rattlers have blue eyes, all species, and for how long?
Yeah, thank you for that question. So when they're born, they don't have, their eyes aren't actually blue. But when they're born, their eyes are clear, kind of like the snake that you're seeing on the screen right here. And then what they do is that in about 7 to 10 days, they're going to shed their first skin. And rattlesnakes have skin that covers their eyes, just like all snakes do. And so their skin starts to secrete this kind of like milky substance to help lubricate the skin that they're going to shed all off in one piece. And that covers their eyes as well. And it makes their eyes look blue. It's kind of like a milky whitish blue. And when snakes are have the bluish eyes, and this is adults, when they shed about once a year or so, we'll have that as well. It's just predictable to see it in the baby rattlesnakes right after they're born. And we say they're in the blue, and it means that they're about to shed. And then what happens is right before shedding, that substance kind of goes away, and then the shed comes off, and then their eyes look completely normal like this again.
Cool. Jeff Marbeck asks, has there been any evidence of snake fungal disease in Colorado or the Colorado den?
Yeah, thanks for asking that. So we haven't been swabbing them for snake fungal disease, but we have seen fungal lesions. So we're pretty sure that it is snake fungal disease. The efforts are really increasing now for sentinel swabbing. Even in California here, where there's only been one snake so far that's been found to have snake fungal disease, we have adopted strict protocols on bags, washing bags between snakes. I now have a swab kit to do sentinel swabbing myself, and I've been participating in the Department of Defense Sentinel program, where they have been swabbing all the snakes on military bases to see how far it's spreading. So I don't have an answer for you specifically in terms of like doing a PCR in Colorado, but I'm pretty sure that they do have it. You don't see, because it's so dry, I think is why you don't tend to see those grossly disfigured snakes like some of the ones you see out east. For anyone who doesn't know about this is a emerging infectious fungus that seems to be really common now in the South and also in parts of the Midwest. And it's kind of eating away at some snakes' faces, and some snakes live with it and they have it seasonally, and then they recover, and it's killing a lot of other snakes too. And so we see little tiny lesions that there probably is fungus, but it's never been confirmed with PCR.
So I'm going to combine inquiries from Jack Forbes and Dave Holzman. How many babies does a female produce in a birth, and how has the population of the den grown over time? And that was from Jack Forbes, and Dave Holzman is interested in possibly putting a camera on snakes in Massachusetts that appear to have a low population, but they're not sure.
Yeah, great, thank you. So the whole question of how many babies snakes have, it depends so much on the species, on the population. In Colorado, the females have approximately 8 babies, and that's because, and that I have good data on because I have palped so many of those snakes, and they're very pregnant, so you can just bloop, 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 you can feel. It tends to range between about 7 to 9, but sometimes 2 to 5, mostly 8. Here locally, they're fewer, so usually about 3 to 6 is common for the Southern Pacific rattlesnakes here. What was the second part of that question? Was it how many?
Let's see.
I'll answer Dave's while you get that. So Dave, hi Dave. Yeah, I mean, I think that putting a live cam on a timber rattlesnake den would be absolutely epic. I know a number of people who know some places in Massachusetts and other places where that could be done. The issue is that you really, if you're going to invest in those live streaming or even just the time-lapse cameras, the good ones, you want to have a place where they hang out. So you really want to have like a den or a rookery where there's significant action. I think what you're talking about is like, you're not sure if the snakes are there, then if that's the case and you want to see, then doing the time-lapse camera is your best bet. There's people who, like, when I was just down in Southern Arizona, there was a gentleman, I'm not sure, I think he was here tonight, but I'm not sure he wants me to use his name, so I won't. But he's been using time-lapse cameras to study snake movement in and out of a den there for many years. The infrared motion sensing is not appropriate, I can tell you that much, Dave. It's not going to catch the most of your snakes moving because they don't move fast enough, and sometimes because the snakes are not warm. So don't try to do that like you would for regular game camera. Set it for like every 5 minutes and then come back and review it after a while. Invest in a camera that's good enough to hold a a good memory card where you can get lots of data. That's your best way if the goal is to be like, are there snakes there or not? What was the second?
Second half of Jack's question is, how has the population of the den grown over time?
Oh yeah, thank you. How's the population of the den grown? So I assume you're talking about the one in Colorado. So again, we don't know for sure because we've only been, like actually studying it for 2020 and 2021. And Scott Boback was up there, doing some smaller amount of market capture before that. However, though, there is, I think it was like a newspaper clipping or something from long time, from decades ago. I can't remember what decade it was in, but from decades ago, from that same peak, saying that there was a guy who would go up there and collect rattlesnakes, and he would collect them and make snake oil out of them. So he was a snake oil salesman. And so it's been known for many, many decades. It's a place where there's tons of snakes, and I can't tell you how much, the population is going up or down, but just by the looks of it and by the surrounding topography, I would be very confident in saying that this place has been a major hibernaculum for probably hundreds and hundreds of years, and will hopefully continue to be too.
It seems like we've actually gone through all the questions, but
Great.
I will say that Jeff Lem says that he's monitoring Ruber dens every week and he needs cams.
Let's talk, Jeff. It's about time I want to come down there anyway. It's about time Ruber was the first rattlesnake species I ever saw in the wild down in Palm Springs area, and I would like to see them again. So I'm gonna come visit, Jeff. There you go.
Right on.
Well, that's it. Everything else in chat is just very complimentary, and thank you for presenting, and I will echo that.
Thank you. I really enjoyed giving this talk, and I hope some of you will become volunteers for the project.
Oh, there's several people who are excited to do that based on their comments. So
Awesome.
and now I think I might have something to do with my Monday morning coffee.
Yes, exactly.
Before I start the day.
Exactly.
All right.
Thank
well,
you.
Cool. I'm gonna stop recording and